Welcome to our mathematics tutorial on solving particular integrals using the differential operator method. Today we'll explore 5 solved problems to enhance your understanding. To find the particular integral of the differential equation d square minus 3d plus 2 applied to y is equal to e power 5x. First observe that the right hand side is e power 5x. So we use the rule replace d by 5. Now the particular integral can be written as pi equals 1 divided by d square minus 3d plus 2 applied to e power 5x. Next substitute d equals 5 into the operator pi equals 1 divided by 5 square minus 3 times 5 plus 2 multiplied by e power 5x. Now simplify the denominator. 5 square is 25. So we get pi equals 1 divided by 25 minus 15 plus 2 multiplied by e power 5x. Now simplify further. 25 minus 15 plus 2 equals 12. So finally pi equals 1 by 12 e power 5x. To find the particular integral for d squared plus 9 applied to y is equal to cos 2x, replace d squared with minus a square. Here a is equal to 2, so d squared becomes minus 4. Now the calculation is pi equals 1 divided by d squared plus 9 applied to cos 2x. Next substitute d squared equals minus 4, so we get pi equals 1 divided by minus 4 plus 9 multiplied by cos 2x. Now simplify the denominator. Minus 4 plus 9 equals 5. So finally, pi equals 1 by 5 cos 2x. To find the particular integral for d minus 2 whole square applied to y is equal to e power 2x. First observe that if d is equal to 2, then the denominator becomes 0. So this is a failure case and we use the rule 1 divided by d minus a whole power n applied to e power x is equal to x power n divided by factorial n multiplied by e power x. Here a is equal to 2 and n is equal to 2. Now apply the formula directly. Pi equals x squared divided by factorial 2 multiplied by e power 2x. Next simplify. Factorial 2 is equal to 2. So finally pi equals x squared divided by 2 e power 2x. To find the particular integral for d square plus d applied to y is equal to x square, we apply the binomial expansion 1 plus x whole power minus 1 is equal to 1 minus x plus x square minus and so on. Now take the lowest degree term common, d common, so we get d multiplied by 1 plus d. So the particular integral becomes pi equals 1 divided by d multiplied by 1 plus d applied to x square. Now rewrite it as pi equals 1 divided by d multiplied by 1 divided by 1 plus d applied to x square. Next, apply the expansion. 1 divided by 1 plus d becomes 1 minus d plus d square minus and so on. So we get pi equals 1 divided by d multiplied by 1 minus d plus d square applied to x square. Now apply the operator step by step. First, d applied to x square gives 2x. Then d square applied to x square gives 2. So we get pi equals 1 divided by d applied to x square minus 2x plus 2. Now integrate term by term. Integration of x square is x cubed by 3. Integration of minus 2x is minus x square. Integration of 2 is plus 2x. So finally, pi equals x cubed by 3 minus x square plus 2x. To find the particular integral for d squared plus 1 applied to y is equal to sine x. First observe that d squared becomes minus 1. So the denominator becomes minus 1 plus 1 which is equal to 0. Hence this is a failure case and we use the rule pi equals x multiplied by 1 divided by f dash of d applied to sine x. Now differentiate the operator. F of d is d squared plus 1. So f dash of d becomes 2d. So we get pi equals x multiplied by 1 divided by 2d applied to sine x. Now apply the operator. 1 divided by d means integration. So we write pi equals x multiplied by 1 by 2 integration of sine x. Now integrate. Integration of sine x is minus cos x. So finally pi equals minus x cos x by 2. In summary, for exponential functions, replace d with a, and if the denominator becomes 0, adjust using the failure rule. For trigonometric functions, use the rule d square is equal to minus a square. For polynomial functions, apply the binomial expansion using the binomial theorem. Thank you for watching this video. If you found it useful, Please like, share, and subscribe to the channel for more lectures. And remember, 1 divided by d represent integration